All right. Hello and good evening, everyone. This is Ankit. I'll be your trainer for the day. So we will be continuing with the concepts of OOPS. Last time we had looked at inheritance and different types of inheritance. Today we will continue with the other topic. Let me share my screen and let me open the Jupyter notebook. Oh, so I think last time we had looked at an example of multi-level inheritance as well. Today, what we are going to do is we are going to start with a concept called as polymorphism. Now, class polymorphism is a word which means that multiple forms. See, the word means multiple forms. Technically speaking, it means that you can have one or more functions which are present in your class. So for polymorphism, what I'm going to do is today I'm going to do two things to explain polymorphism. Let me quickly do that. Okay. Let me quickly open. Let me give me a minute. What is this? Okay. All right. So where is Zoom? All right. So now the question is, see, we have completed the part of inheritance, and now we know that if there is already a class which is available, there is functions which are available, and you have a requirement wherein you need to use the same class, same data parameters, same functions, you can always go for inheritance. Now, what happens? This has given rise to a small problem in the world of programming. Okay, let me not say it as a problem, rather it's a concept, and it's okay, let me say that it's a slight uncomfortableness which has come. Okay, slight issue. The issue is that you have very limited function names which are available. Okay, and then we'll come to that. So let me tell you that polymorphism is a concept that assures that data can be displayed in more than one way. It means that you can have one function name in your parent class and you can also have the same function name in your child class. So let me do one thing. Best way to do is let me go ahead and quickly give you an example of what I'm trying to say. I'm going to create a simple class, and the class, let me create a class called as shape. So what I'm going to do, I will say class shape, and then I'm going to define a function within it. Now, this is something which I wanted every one of you to pay attention. I'm not going to define the constructor function. The reason, because I do not have any data members, I do not have any attributes to be defined for this class. If I create an object of class shape, I do not want it to have any data parameters. So if you do not have any attributes, if you do not have any data members, in that case, you do not have to write down the constructor function, because the objective of constructor function is to assign values to data members. But since you do not have any data members, you can ignore the init or the constructor function. So this is the first concept. And what I have given is I have written down a function called as getLines. So let me repeat. Today we are starting with the concept of polymorphism, in which I'm defining a new class shape. This class shape does not have a constructor function. Why? Because I do not want to give any data members. The objective of a constructor function is to assign values to the data members. But if you look, since I do not have any data members, I do not need to write down a constructor function, because I don't have a requirement of assigning any values to your data members. So I have written down inside the class shape, instead of the constructor function, I have written down another function called as getLines. So when I say instead of, it means that I can have multiple functions, right, apart from constructor. So this is one common function, one general function, getLines. And this function will print the statement, I am a shape, I can have multiple or any number of lines. Okay. Now, what I'm going to do next, I am going to say, I'm going to define another class, and let me say triangle. So when I define this triangle class, what I want to do is I want to inherit the shape class. So how do we perform inheritance? Inside this class, round bracket, we will give the name of my parent class. What does this mean? This means that my triangle is the child class and I am inheriting shape class. That means my shape is the parent class. It also means that any object that I'm going to create for triangle will have access to the getLines function. Right? If you remember, if we revise quickly, what was inheritance? Inheritance was if you are trying to inherit a class, that class is called as the parent class. Then we have the child class, which is inheriting the parent class. If you inherit a class, the parent class functions and data members are available to your child class objects. Okay, so cool, you say cool, I have access to getLine, but what I'm going to do here is I'm going to write down the same function again, getLine self, and I'm going to print in this function, I am a triangle, I have 3 lines. Okay, now I'm going to register this inside my Python memory. Now the question that comes to your mind is, I have two function getLines. See, if I have to define, let me say S1 is equals to shape. So what is going to happen? I'm going to create an object of class shape. By default, Python will go inside the class shape, look for a constructor function. You do not have a constructor function. Why? Because we are not passing any values to be assigned to the data members. So it will simply create one object S1, and the only function that you can call for S1 is getLine. So let me create this function and let me call S1.getLines. What will happen? The moment you call S1.getLines, the flow of control goes inside getLines function. You will have to pass self as the current instance of the object. So S1 will go and sit here, and you will print I am a shape. I can have any number of lines. The corresponding print statement has been printed. Now let's see what will happen. Let's see what will happen if I create an object of class triangle. So let me say T is equals to triangle, or let me say T1 is equals to triangle. Okay. After creating the object of class triangle, if I try to call the getLines function. Now this is an interesting concept. We are in a very interesting scenario. Okay. What has suddenly happened? If you see, I have not executed anything. Let me clear the output. I have not yet executed the cell. If you see, I have created a triangle object. The flow of control will go inside class triangle. The getLines function is being called by this object. T1 will go and sit itself. But now the problem is inside class triangle, there are two getLines function that will be available to the object T1. Do you all agree with this? Do you all agree with this that there will be two getLines function? Why will there be two getLines function? One that is coming from the parent class and one which you have defined in the child class. Is everyone with me? Can I get a yes? That there will be two getLines function that Python will encounter for class triangle, right? Class shape is simple, you have one. But since triangle is inheriting shape, we say that all the parent class functions and data members will be available to the child class object. The moment you call t1.getLines, ideally Python should get confused because you have access to two getLines function. See, in this case, this is what polymorphism means. It means that you can always overwrite the function which is present in your parent class. This is also known as overwriting of the function. Why? Because if you execute this, the output shows that only the getLine functions of your child class is executed. This was the function that was invoked. The parent class function did not get invoked. So what do we learn here? Polymorphism means you can always define two functions with the same name. So when I say two functions with the same name, it is not supposed to happen inside the same class, but rather if you have a child class, you can always define the same function as that of your parent class. And in that case, if you create a child class object, always the child class function will get invoked. Who will get preference? If you create a child class object, the child class function will get preference. It will not go to the parent class function. The preference will be given to the child class function because you have written this function. So imagine something like this. You already had a function getLines. Okay, now you are defining a new function getLines. So automatically, this is what will be registered in the Python memory as getLines for a triangle object. The parent class function will not have precedence. You will have the preference. The child class will have the preference. So now, till now, this is clear. Right? Is everyone good till now? Is everyone good till now? Yes. If yes, then you should have a question that if I want to access my parent class constructor, if I want to access my parent class function through my child class, what can I do? I'll tell you what you can do. I'm going to define a new class called as square, and I'm going to say it is inheriting the class parent. And within this, I'm going to again implement polymorphism. I'm going to give the name getlines. I'm going to say self, and then what I'm going to do classes. I am going to, you remember that we could call the parent class function with the name of the class itself. Okay. Now in this case, one more way that I'm going to tell you is you can always say super. Okay, use super and say getlines. Now what will happen when you do this class, when you do this, what will happen is this is another way of calling the parent class function. See, if I go back to the constructor function, what I had done here is I from the constructor function of my child class, I had called the parent class constructor. Right there, I had to pass certain parameters as well, where you have to pass self as well. But with the help of the super one, this super will also do the exact same thing. You are going to call your super class constructor. You're going to call your super class function. That's it. Super followed by round brackets is equivalent to what we did in employee underscore init. This will tell you that go to the super class function, call the getlines function, and then you can also write down here, let's say I am a square. I have 4 lines. So if I execute this s1 dot shape, t1 dot shape, now what I'm going to do is sq1, I'm going to define a new object for the class square. Please note that every time you change the class, you will have to re-execute the class code so that it gets registered. The new definition gets registered in the Python memory. Also, you will have to recreate your objects so that the new functions will also get bound to the objects of your class. So now what I can do, isq1 is equals to, I'm going to create a class called as square. I'm going to create the object of a class called as square. And then what I'm going to do is I'm going to call the function getLines. Let's see what will happen now. What will happen is an object of class square will be created. And when I'm calling sq1, which is the square object, and I'm going to call getLines, again, the square object will have access to two getLines function. One will be coming from your parent class, one that you have defined here itself. So now what it will happen is automatically the child class function will get the preference. So you will execute this get lines, but within this get lines, you have called super dot get lines. It means that you have called the super class, and from the super class, you want to execute the get lines. So the flow of control will go to the get lines function of your super class or your parent class, and it will print that I am a shape. I can have any number of lines. So the first line that will be executed is this. Then the flow of control will come back, and then you will print I am a square, I have 4 lines. Let's see if that happens. If I execute, you see that first, because of the get super dot get lines, you can see what we have is the get lines function executed from your parent class, and then the final logic of your child class will also be executed. So yes, you can call the parent class function from within your child class function. That is possible. If we are good, do you want to, let's quickly try this out. Let's quickly make a note of this.
Ankit, one note, in every class, child class, we are mentioning like triangular, whatever, square, whatever we want, a hexagon if we keep, and in
Mhm.
brackets, we are mentioning as a shape because it's a parent class which we are defining already defined.
Yes.
Like the same way, in place of shape, if we keep triangle, class triangle is there. Let's take a class square, and in place of shape, if we keep triangle, how it will be?
So see, this, what this does is, this means that you are trying to inherit the shape class, right?
Yeah,
If you give triangle, that means square is going to inherit the triangle class. In
yeah,
that case, if you call super, which function will be called? The get lines of your
okay,
super class.
triangles. Yeah,
Yes. So if the proof is this, you see, if you then execute sq1 dot get lines, the flow of control will go here. This for
yes.
now your parent class is triangle, so this
I'm a
line.
triangle. I have 3 lines. Then it print. I'm a square. I have 4 lines like that.
Yes, yes. So whatever you're inheriting, this means that you have inherited from that class. That's it. You can inherit from any class based on your requirement.
Okay. Whatever we mention in that, that will be called as a parent class, and as a thing.
Yes.
Yeah, simple. Yeah, thank you.
Yes. That's a good question. Actually, you can define one more function here as pentagon and try to execute triangle so that you remember in future that this
Yeah,
is how it works, right?
I'll try that right
Yes.
now. Thank you.
So I want everyone, in fact, to try this out. What Vinay mentioned, we can all try this out. You can define one more function. You can say class, let's say pentagon, and instead of directly inheriting shape, you can inherit, let's say, square or triangle. Just for the practice, just for the sort of practice. Okay. So that you know when this indicates that you're trying to access the triangle or you're trying to inherit the triangle class. Then you can mention the same function, get triangles. And I'll let you know why we had this specific requirement where we can redefine the same function name, why it does not result in error and everything. Don't worry, we'll get to that. And then you can print, I am pentagon, I have 5 lines. And then when you create the object, you can create p1 is equals to pentagon. When you call p1.getLines, see, you will have the superclass code got executed, and in case of pentagon, the superclass was tried. So let me zoom out a little so that you can see all the codes.
And actually, one more addition to this, like in triangle, we already mentioned shape as a parent class, right? Why it's not calling that? Like class pentagon inside, we mentioned parent class of triangle, but triangle already has a shape as a parent class.
That's right. But in
Yeah.
triangle, you see in the getLines function, you have not called the parent class function. Your super.getLines calls your parent class function, right? In triangle, there is no super.getLines. You're not calling the parent class function.
Okay.
Okay,
If I
so
mention in place of print, like above that, if I mention super and super function dot getlines, if I mention there, it automatically go to shape and come down to triangle, then come down to pentagon, right?
correct. So instead of triangle, if you give square, because we already have the super.getLines in square, right? If you
Yeah.
give square here, you see what will happen? Your 3 lines should be executed. First is shape, then is square, then is pentagon. Why?
Perfect.
Because when you call the parent class function of your pentagon class, it went to square, which in turn is calling its own parent class function, which is shape. So this line got executed, then the flow of control came back here. This line got executed, I am a square, then the flow of control finally came back here, and this line got executed, right? Because when you call super.getLines, flow went here, it executed the entire function, the flow went there, it executed the entire function, and so on. Make sense?
Yeah, perfect. Just I'm trying one more way. Like, yeah, thank you.
No, so this is good. See, class, it's important to play around. The more we play around, the better we learn. So yes, please try playing around. Let me know, class, once done, let me know. All right. So now, class, the question that arises is, why is it required? Like, why is there a feature wherein you can give the same function name? Right? Why is that feature required? So there are two things why this feature is required. Okay. Because if you see, I can call my parent class function. I have the same name of the function. Why to create so much confusion? Why to give rise to a concept wherein you can give the same name? Polymorphism means many forms. This function has many forms. You see, we have this function define lines, get lines in 4 different classes. It can be displayed in more than one way. But why? The reason is, see, today we are writing very simple classes just for theoretical purpose to understand multiple concepts. But in future, when you write and develop a full-fledged end-to-end large-scale application, it becomes very difficult for you to determine what names should you give to your functions. If you remember in the very first session, I would have mentioned that there are 4 to 5 standards or general principles on the basis of which you should give your variable names. And the sixth principle that I said is my own principle, and it's an unsaid rule that you should always give the names of these variables or the names of functions or names of classes in such a way that they make sense. You go back to these classes, you should understand. See, get lines is a function which is returning to me the number of lines that a particular shape has. What happens is there is a point of time after which you stop getting new ideas. It's not preferred to give _1, _2, _3. These kind of function names, these kind of variables do not make sense. What is the meaning of _1? Is this the first variable? No. We just give _1, _2 because there are some existing names which are available. So we don't want to do that because tomorrow, let's say if you write down get lines _1, _2, _3, _4, how will we come to know? It becomes very confusing which function belongs to which class. Is it inherited? Is it overwritten? What is happening? Why is it _4? So let me give an example. Let's say if you take any application, and this is not just true for Python, I think this is an overall object-oriented principle, wherein if you take any retailer or Amazon, Flipkart, if you want to know what is a transaction ID, the general function name is always going to be get transaction ID. If you want to know the name of the user, you will say get _name_user. Now, if you write down inheritance, inherit some class, the parent class has the same function name, you will get an error. So now what you want to do? You want to add _1, not preferred. Let us give, so Python developers or the OOPS concept allows you to give the same function name. You can write down get _transaction_ID in 100 different classes with 100 different functions with or without inheritance. It's up to you. Don't have to worry. If it's a different class, you can definitely write down a function. So this is where I am going to mention a very specific word, and I'm going to say that you can define the same function You can define a function with the same name. Let me put it like that. So it does not mean that you should, it means you can. You have the capability. If you want, even after inheritance. See, if these are two different classes, it does not matter. Because if there are two different classes where there is no inheritance at all, there will be no confusion. The confusion arises when you inherit. But even in that case, the rule has been set that your child class will get a preference and you have an option to go to your parent class and invoke the parent class function as well. But this means that these are the capabilities. This is something which you can do and define a function with the same name in child and parent class. So the basic objective is that you need not put underscore once, you can use the same function names. Now with that, what we are going to do is we are going to move to a new topic. And the new topic is called as abstraction. Now to explain the actual concept of abstraction, I'm going to give you a real life example. Okay, this is a topic which is very interesting. And what we are going to do is we are going to understand it with the help of a, let me open the whiteboard. Let me see. If not, we'll go back to Excel. Oh, so what I'm going to do is so I want every one of you to pay attention to what I'm going to say in the next 5 minutes. Okay. It's a general discussion. If you have, you please feel free to add. Let's make it interactive as well. But what I'm going to do is I'm going to tell you how to. You can class. Okay. So what I'm going to do is let's talk about a scenario. Okay. Let's say you are working for an e-commerce company. Let us say any e-commerce company, and this e-commerce company is selling products from multiple categories, multiple things. Take into consideration a company like Amazon, Flipkart, Myntra, anything. Okay. So there is a finance team which sits in this company. And there is a team, let me say the sales team, which also sits in this company. Okay. So I have finance and I have sales. These are the two teams that are working with each other. Both of these are in programming. Okay. So what does sales team have information about? They have the information about who is the customer. So let me say the customer ID. Okay. They have information about customer ID. They do have information about the product. What product are you planning to buy, or what product have you bought? They have information about the price of the product, the date on which you bought, and so on. Okay. And finance team has some other information. They also have customer ID. Obviously, they have the customer ID information available with them. But they have some other information such as what is your, let's say, bank details, account number. Let me say bank name, your account number. It also has a bank name, account number, then UPI ID if required, right? Some credit card numbers, some debit card numbers, credit card, debit card, and so on. Okay, so if you see, the finance team has what? It has the banking related details of each and every customer. The sales team on the other side has transaction related information, right? On which day did you buy what was the price, and etc. So do you all agree that finance team has slightly sensitive information? Do you all agree they have sensitive information? This information should not be shared to sales team. Do you all agree? Yes. This is very sensitive information. They should not be shared with sales team. And they have maintained this proper classification. Okay, they have their own functionalities. They take care of things. Sales will take care of only sales. Now happens is a concept of return. So the moment a customer, let's say customer ID raised a return, what will happen is they know what is the product ID, they know the price, they know the date, everything sales team has. But what sales team does not have is how to process the return. Where should I get the return? Get refund. They want to initiate the refund amount. For that, sales team goes back to the finance team and says, see, Cool. I have the customer name. It's a very good customer. We have the product price, everything is looking fine. The customer has raised a return. And in order to process that return, what I need to do is I have already initiated the delivery related details. Okay. So delivery and shipping, everything is taken care by the sales team. But what I want to do is I want to initiate the refund process. Please give me the bank details and everything. So the finance team says, no, we can't give you bank details. The sales team says, how will we process the refund then? So in this case, there is a concept of abstraction that comes into picture. Okay, what will happen is, let me scroll down a little bit. What will happen is, the moment you see, so let me repeat, you have a finance team, you have a sales team has transaction related data, finance team has sensitive information such as the banking details, account number, UPI ID, which should not be shared with everyone. Sales team also implements a concept of return wherein a customer can return a product. And in that case, there is an additional step that the sales team has to execute is to initialize and initiate the refund process. Now, to complete this refund process, sales team says that we need the bank details of the customer so that we can initiate the refund or we can send money to that particular account. We need to show this to the customer, right? At least tell me what is the detail. At least give me the UPI ID so I can tell that I'll be returning it to you in UPI. The finance team says no. The information is sensitive and I cannot share these details with you. So they decide to then implement a function or they then decide to implement a concept of abstraction. This is where abstraction comes into picture. Abstraction is a very strong pillar of OOPS. Abstraction is a concept wherein one class can tell you, or basically it hides the internal working. Abstraction is let me say, abstraction is a process through which the internal working of the function is hidden from the users. So basically, the users know what the code does. They will be aware about what the code does. What they don't know is how things are happening. Okay. What they will not know is how it works. Right? Not how, let me say, not how. So what will happen is finance decides to implement this abstraction and finance says, see, I am going to define an abstract class. Okay, I am going to define an abstract class. What is abstraction? It will say that abstraction is used to hide the internal working of a function, within which it says, I'm going to define an abstract function. Now, abstract class is a class which has abstract functions. If you have an abstract function in your class, you will define that class as an abstract class. This abstract function's name I'm going to write down as get refund. Okay, I'm going to write down as get refund. Now they are going to tell the sales team that do one thing. Okay, you inherit the abstract class. You inherit the abstract class. Why are we going to say that inherit the abstract class? I'm going to tell you why. Inherit the abstract class. So whenever you inherit the abstract class, you have to forcefully implement the abstract function. Okay, you have to forcefully implement the abstract function. Now, what does this mean? It means that you are telling that you inherit, see, simple thing. You inherit my abstract class. This means your get refund should be available in your sales function. But now you will have to implement the get refund function. So let me quickly put it diagrammatically. What I'm going to do is I'm going to define finance, which will be my, let's say, abstract class. Okay. I'm going to say this is my abstract class. The function that we are going to have inside this is going to be get refund, which is an abstract function. This is my abstract function. Now I'm going to say sales, you will inherit the finance class. So sales is inheriting the finance class. In this case, what will happen is, see, now to any object of the sales class, which is your child class in this case, the get refund function will be accessible. But the moment you define it as abstract, so you see, when we were discussing about polymorphism, I said you can define the same, you can define a function with the same name. Do you define? I said I put a lot of stress on you can. That means it gives you an ability. In case of abstraction, what happens is you will have to. That means you are forced to define the same function name. And why, I will tell you. See, you will have to define the abstract function. If you do not define this abstract function, what will happen is you will get an error. If you are inheriting an abstract class, if a child class inherits the abstract class, the child class is forced to define the get or define the abstract function. It is forced to, it will have to define the abstract function. Now let's understand why. Because finance team will do what? They will say that we are going to control how to deal with the banking related information. Okay. So they will do what? They will say that, okay, I will get all the banking related information and this function will return, let's say, it will simply return, okay, return the bank details. It will return the account. See, if it was a UPI transaction, it will return the UPI ID. If it was a bank account or a credit card transfer, it will return the credit card number or the bank account number. So accordingly, what it will do is it will, let me say, it will connect to the database. It will access the sensitive information. Okay. It will access the sensitive info. It will get the sensitive info. And then for the customer, for one customer that you want, it will return the account details. Okay, whatever was the account detail that was required. Now what will happen is class, what will happen is your child class, since it is inheriting your abstract class. So since it is inheriting a parent, which is an abstract class, it will be forced to write down an abstract function. It defines an abstract function. By default, you will have to call the parent class function. Right? You will have to call. Why? Because once you call it, you will get these account details and then you can write down your own logic. What you want to do with this account detail, you want to let the customer know this is the account where your information will be shared or where the amount will be refunded back. This is, or you want to initiate the account, you want to transfer some money in this account, do whatever you want. But what will happen is you will have to write down the same function. You can use the function. So what will happen is, see, now the idea is if you go back to the definition, how these things are going to happen, right? What is the database? Where is the data stored? What is the logic? How you're getting the account details? This is something hidden. If you call super.getRefund, it will return the account detail directly. So you know, the child class will know that the parent class function, the abstract function is going to return to me the account details. But how? This part is totally controlled by the parent class or the abstract class. Okay, let me quickly revise the entire concept. Let me quickly go right from the beginning. I know too many terms, too heavy. I know that, see, I have experiences in a lot of classes that abstraction is something which people find it very difficult to get it in the first go. Don't worry, I'm going to repeat the entire thing. You will have the session recording. You can pause and play and understand as well. Okay, but let me take you through the entire example once again. Okay, let's say there are two. So we are talking about an e-commerce company. It can be, we have multiple e-commerce companies. So one of these companies, let's take an example where they have two departments. The first department is a finance department, which has sensitive information and deals with sensitive data. The data can be the customer ID, bank name, all bank related, account related, UPI ID, debit card, credit card, whatever you see on your payment page. That payment page information is totally controlled by finance team. And now we have a sales team that deals with transaction. When I say transaction, it means that they will have the name of the customer, the product, when did they buy it, what was the price, what is the amount, etc. What they don't have is the bank related information. And they are happy. See, because when the customer pays, finance takes care of it. Sales team does not come into picture. But if a customer raises a refund, now is the point when sales team needs these banking details. Why? Because the sales team wants to refund that amount into the customers, whatever source through which they paid, right? It could be a bank account number, let's say UPI ID. So they want to return the money to the UPI ID, but they don't even know that it was the UPI ID through which the payment was sent, because that's sensitive information. They have no idea how to access this sensitive information. They have no idea of what did he pay through UPI ID? If so, what is the UPI ID? They have no access to these data. This is something which finance says, no, I will not share with you. You want to initiate a refund? I'm going to define an abstract class. So why I'm going to define an abstract class? Because see, as a part of an abstraction, I am going to hide the entire functionality of how do I get this data, what exactly is this data, but you will get one output from me where the refund has to be sent. I will not tell you how did I access it, what are the different other details, how I'm going to finalize that this is where the amount has to be sent. I'm not going to tell you anything. The only thing I'm going to tell you is that take this number and return the amount here. This is the UPI ID, return the amount here. How did I get that? I'm not going to tell. So abstraction is a concept through which you hide the internal working of your function, but the users know what a particular piece of code is doing, but they will not know how it is doing because you have hidden the functionality hidden. You have kept the functionality hidden. All right. So you finance team determines that, okay, you want to write down a function called as get refund and you want to send the refund to a particular account number. So what these people wanted is they wanted to know the information. Tell me where is the database, where what all information, give me all the customer information, all the UPI ID information, all the bank information. And what did finance say? Oh, don't try to be smart. I am going to write down an abstract function. I will not tell you all the other information. I'll just give you one information, use it if you want. And in order to do so, you will have to forcefully implement the same function, which is an abstract function. In this abstract function, I'm going to write down some logic. You can call my abstract function, use the output, but you will have to write down the get refund, which is your own, right? So what does abstraction do? Abstraction is a concept wherein if a child class inherits a parent class, abstraction will enforce the child class. They will have to always redefine the same function and they will have to write down some of their own logic. Okay. So what I'm going to do, classes, I know that this might be slightly confusing. I am going to go back to our notebook and let's try to implement abstraction with the same example of shape and triangle. Okay, let me go back to and let me implement this with the help of shape and triangle and let's see if it makes sense. Meanwhile, let me do one thing. Let me export this PDF. Let us go back to our own example. So let me first write down the definition. Let me first write down the definition. Abstraction is nothing but the internal working of a function. It's hidden from users. Let me say this. Okay. Also, it means that users will know, or let me say, users know what the code does. You will know what the output is, what is the code going to do, but not how it is doing it. That is something which is hidden. So I know that a lot of students think that the functionality is hidden, internal working is hidden. That means how the code is going to execute is hidden, but not the users of your or rather the child class will be aware that what you're going to do. How is something which defines the functionality in the internal working that the child class will never know. Cool. So first things first, okay. I am going to import something called as ABC. So ABC is a package from which I am going to import a class called as capital ABC and abstract method. Okay, abstract method is a generator function, not a generator function. Sorry, abstract method is a decorator function. Okay, so see, now this is a new concept for a lot of you. What I'm doing is I am importing certain packages. I'm importing certain classes and certain functions. Now, class, what happens is, as we go ahead in future, we are going to do a lot of importing. I have planned one session where we will create our own class and we'll try to import it in a different place. We will do that as well. But for the time being, what I can say is, your Python comes installed with multiple different packages. Okay, you have a lot of packages such as math, numpy, pandas, matplotlib, seaborn. There are a lot of packages which come pre-installed when you install Python for the first time. They are by default always available in your system. But if you want to use them in your current session, you will have to import them. So import is a statement that can import classes, functions from different packages. Okay. But what happens is, what I have done is there's a package called as ABC. I don't want to import the entire package. You can import the entire package as well. That is also correct. But I don't want to do that because obviously the more number of packages that you currently import in your session, your memory becomes less, right? Because everything gets loaded into your memory. When you do an import statement, that package gets loaded into your memory and is available for you to use. So I don't want to use the entire package. From this package ABC, which is small, this is specific, okay? The name of the package is small ABC abstract class package. You import a class called as capital ABC and a method called as abstract method. You execute this. This is okay.
Sorry,
Let me,
sorry, sorry
yeah,
for interruption.
go ahead, go
You
ahead.
mentioned from ABC import ABC. You mentioned, right?
Yes.
It's a general term. In place of ABC, we can give XYZ or something, or
No,
else
no, no,
ABC
no,
it's
no, no.
inbuilt library.
No, no. So ABC is an inbuilt library. So this is a package. The small ABC is a package which has been specifically designed to implement abstraction in Python. You cannot use any other name. This is something which will be available in Python. The class name capital ABC is the exact name that you're supposed to use because the Python developers have developed exactly these same packages to implement abstraction in Python. So no, you cannot use from XYZ. So even in future, when you're trying to import a package, that package name will be fixed. Whatever names the developers have already given, you can only import that. So let me put it in a different way, right? When you copy a file from place A to B, right, you will have to copy the exact same file, right? You can rename it, but you will always have to first copy, okay, I want to copy file A. So you will have to copy A. Similarly here, if you're trying to import a particular package is what? See, package is basically, let me tell you like this. Let me, to make it more clear, let me go to the whiteboard and let me tell you like this. See, let's first understand what does package mean. Package is nothing. See, you all know what a class means, right? When I said from ABC, import capital ABC, this I said ABC is a class. That means someone has defined the class name as capital ABC, right? That is why you are planning to import the class ABC. Someone has defined it ABC as a class, so that's why you have to import the exact same name. Now, package is nothing, but it's a .py file. Okay, also a lot of people call this as a library. It's a .py file. What happens is inside your package, you will have a .py file within which you will write down multiple classes. You can write down functions as well. So basically what you're telling Python is when you say from ABC, it means that there will be a file somewhere present in your Python installation files where the file name will be abc.py. So the moment you say from ABC, Python goes inside its library and starts looking for abc.py. Inside abc.py, I am going to import class ABC. So inside this, there will be a class definition, which will be like which will be like class capital ABC, which will have its own definition. So I'm saying go to the abc.py file and load this class into my current RAM, into my current session. That is why you cannot have anything else. You will always have ABC because this is the specific file. Vinay, does that answer your question? Yes? Great. Yes. So ABC is the larger file, as in ABC is the package here. Small ABC, let me say small ABC. So small ABC is the name of the package, which is the .py file, and capital ABC will be a class which is present inside that .py file. So if we go back to our notebook, if you see what I have done is, I have imported from this package, I am trying to import a class ABC and a function called as abstract method. Similarly, a function which will be defined inside your package, I can directly install it here. Now, please note that Python does not, see in inheritance, there is always a way. When I say inheritance, you guys came to know that, okay, it was syntactically done by getting the employee class. You give, this is the syntax to implement inheritance. Similarly, polymorphism means you can define multiple functions with the same names. Similarly to these concepts, in order to implement abstraction, Python developers have created these classes, and these are the classes that will be used to implement abstraction. Now, ABC is a class which is used to define an abstract class, okay? And abstract method is nothing but it's a function to define an abstract function. I will tell you, don't worry. The moment we go in, you will understand what is happening and why is it happening. Okay. But if you want to implement abstraction, you will have to first import the class ABC and the method abstract method from your package ABC. This is something which you will have to do. Now let me say class shape. I'm going to implement my abstraction. So what did I say? I'm going to say that my class shape is going to, I want to define this class as an abstract class. My objective is define shape as an abstract class. Okay, shape as an abstract class. This is what I want to do. So let me first write down the simple definition. If you remember what we did is this was the function define get lines. Like, let's me first write down how the normal class would have looked like. This is function. Then I think I was printing I am a shape. I can have any number of lines. Okay. Now, what I want to do is I want to define this class as an abstract class. That's my objective. So the first thing that I'm going to do is to define a class as an abstract class, right? To define a class as an abstract class, I have to inherit ABC. Okay, to define a class as abstract. If you see, then I will have to say ABC. The moment I inherit capital ABC, this class definition makes it shape as the abstract class. So now if I want to define a class as an abstract class, one simple thing that I need to do is I need to inherit the capital ABC. Right? Now your abstract class can have an abstract function. To define an abstract function, I will have to use the decorator syntax. Now pay attention very closely to what I'm going to do. I'm going to say at the rate abstract method. Now, at the rate abstract method, the concept is also known as decorator. What it is going to do is, see, decorator means, let me tell you what does decorator means. Decorator is a concept, or decorators are used to modify the working of the function. And what modification are we doing here? The modification is, I want to enforce my child class to implement this function. Let me again go back. Okay. So what we're trying to do, we are trying to implement inherit. We are trying to implement abstraction. So how will you define an abstract class? If you simply inherit capital ABC, the class which inherits capital ABC by default becomes an abstract class. It's as simple as that. Inherit capital ABC, you have defined that class as an abstract class. Then how do I define an abstract function? I will decorate my function with an abstract method. Okay. So if I want, what does abstract method do? This is the syntax, at the rate abstract method. At the rate abstract method, the concept of writing this in above a function. So you can have there are different decorators. At the rate is a concept which is called as decorating a function, and you have decorated with this function, which is abstract method. So why are you decorating your get lines with abstract function? The concept of decorator is it will modify the behavior of your function. And in this case, abstract method has been written to modify the behavior in such a way that if any class inherits this class shape, which is an abstract class, they will be enforced to write down the getLines function. Okay, let's see. Let me define a class triangle. And let me inherit my abstract class. So what I've done here, I have an abstract class which has an abstract method. The abstract method says that the child class will be enforced to write getLine function. So let me first begin with, let me not write the abstract function. Okay, what I've done is I've written down, excuse me, I've written down a function called as getAngles, and I'm going to say print another function. I'm just going to say this. Okay. Now the question is, I have been shouting at the top of my lungs saying that if abstraction means I will have to enforce this function, I will have to define this function in my child class. How I'm doing it? With the help of decoration. What is the decorator function here? Abstract method. What will this do? This will enforce my child class to implement the corresponding function. But see, what did I do? I inherit the abstract class. I did not define. Say, okay, Let's register this in our memory and let me do one simple thing. I'm going to say T1 is equals to triangle. Let's see what happens. I will create an object. The moment I do this, you see that you have got an error. It threw an error. Can everyone see? It is throwing an error saying that you cannot instantiate abstract class triangle with abstract method get lines. It says that since you have inherited the abstract class, there is a function coming from get lines, but this function is an abstract function. You cannot have an abstract function here. You will have to define the function get lines here. The moment you define get underscore lines, you will implement polymorphism. You will define get lines. Okay. And you will say define, let's say, see, you can call, let me first call my super class function because I'm going to use it. Obviously, I'm going to say get lines so that I can call my parent class function. I can use the logic already implemented and I can write down my own logic, and I'm going to say print I am a triangle. And you're going to say I have 3 lines. The moment I do this, I have re-executed the class definition to update the definition in the memory. And the moment I create this object, now you see it has successfully executed. Then if I call t1.getLines, the idea is I'm going to get I am a shape because you have called the superclass function and you're also getting this. So see, in your polymorphism, this was optional. You can define a function. But the moment you go into abstraction, you will have to, if you do not define the abstract class function inside your, let's say, child class function, then you will not be able to get an error. Now the question is, how do you ensure that people will not be able to use my abstract class function? How can you say this is hidden? I'll tell you how it is hidden. I'm going to show you one thing. I'm going to say S1 is equals to shape. Let me create an object of class shape, and the moment I execute this, I will get an error. And the error is that you cannot create an object of the abstract class. Your abstract class is something which you cannot create an object of. Since you cannot create an object, you cannot call the abstract function. This is an abstract class. You can't do anything of it. If you want to use it, you will have to inherit it. So you see, only the child class can use the abstract class. And even in that case, the parent class or the abstract class will enforce the child class to implement the same function. So this was finance, which forced the sales class to execute the code saying get refund, but they will never tell how their code is working. Why? Because you cannot create the object of a child class. This is supposed to return an error. You cannot instantiate, you can say create object of an abstract class. This is how the internal working is always kept hidden. You will never be able to instantiate. You cannot create an object of an abstract class, but the child class can inherit the abstract class. In such a case, your child class will be enforced to write down and re-execute the abstract function. If you do not redefine your abstract function, you will get an error. So if we go back to the definition, you remember abstract class. Let me do a quick end-to-end revision. Abstraction is a concept wherein you are trying to hide the internal working of a function. Users will know what the code is going to do, but not how. In Python, you implement abstraction with the help of a package called as lowercase or small abc. This is a package which has a class called as capital ABC and a function called as abstract method. So the first step that you need to do to implement abstraction in Python is you import the package ABC and rather you import the class ABC and abstract method from your package ABC. So first thing, you load this into your session. Then if you want to define a class as an abstract class, you inherit capital ABC. Capital ABC is a class that will define that if you inherit this capital ABC class, you are defining that particular class as an abstract class. So in order to define a class as an abstract class, you simply have to inherit the capital ABC class. But if you define a class as an abstract class, you need to define an abstract method. That is why you will be defining, see, the objective is clear. You're defining an abstract class because you want to define an abstract method. Now you define an abstract method with the help of decorator. Decorator means you will mention this at the rate and you will mention a function name. So at the rate function name, this concept is called as decoration of the function. You are decorating getLines function with the function called as abstract method. Decorator is nothing but it will modify the behavior of the function that you are trying to decorate. And in this case, the modification is you are enforcing the child class to implement the getLines function. You say, cool, you define a class triangle. In the first step, what we did is we did not define your class getLines. What I defined is a direct function getAngles. But what does abstraction say? If you are inheriting a parent class, which is an abstract class, then you will be enforced to define or implement the getLines function. Let's start by not doing it. The moment I do this, I get an error that you cannot instantiate the abstract class function. Why? Because to triangle, only abstract method is available. You will have to define your own function. So I do that, I define my own function, then I'm able to execute it. Now the next question is, why did you say that the abstract class internal working will be hidden? That is achieved by not allowing any object creation of my abstract class. Abstract class, you can't create an object, you can't instantiate abstract class, you can't call any functions. No one knows how it is working. The only thing is they have kept their working hidden. You need some output. I will give you some output, but for that you will have to implement a function that I'm going to enforce you to do that. That's done through abstraction. Okay, I hope the concepts are clear. I know it's slightly more intuitive. Okay, abstraction is something which is intuitive. That's why I always give a real life example in case of abstraction. See, for polymorphism, I didn't give you a real life example. I just said get transaction ID is something which you might have to write down again and again. But in case of abstraction, I think it helps because it's a concept which requires a real life application. Why and where would people use it? That's why I give you an example of finance and sales, but for implementation and for simplicity purpose, let's use our same function classes, shape and triangle, the same functions, getLines, and try to it. Let me give you a couple of minutes. I want everyone try this out. So try out the exact same way. See how I have defined, I did not define getLines, right? How I did not define getLines. Similarly, you also don't define getLines first and try to execute. You should get an error. Then you go define getLines, write this function, then execute, and you should be able to get. So that this concept becomes clear. Is abstract method present inside package? Yes, it is present inside package ABC. Go. As far as I know, it's present inside package ABC because from ABC we are importing the two things, right? It's not native in Python, but it's present inside a package called as ABC. Let me zoom out a little bit.
Ankit, compared to polymorphism and abstraction, here you mentioned abstraction for like security purpose to not show the content what is present in a parent class. But
Yes.
when you used a super class, it will display the content whatever it present in a parent class.
Yes.
Okay, so just here, just you like normally instead of showing that you kept abstraction and you masked it, right?
Yes. So see, what will happen is you can write down a lot of concepts here. See, you can write down whatever you want. You can say, let's say A equals to 10, B, like whatever logic you want, that logic will be written here and you will return something, right? Generally, you will return something here. That will be returned to this place. So let's say in case of finance, it would have returned, this function would have, let's say, connected to the, what do I say? The finance database, okay? Then it would have get the details and then you will return the details, okay? So what will happen is, in this case, when you return these details, these two lines, whatever you're doing, no one knows. It will only return, let's say, the UPI ID or the bank account number, and you will catch here that this is the bank account number. That's it. You will get back the bank account number. It will control, the parent class will control what is being returned. It will not, the other logic, how you connect it to the finance database, what are the details that you need to pass, what is the server where this database is stored, which query are you writing, what is the name of the table, what is the name of the column, all these things will be hidden. But what will happen is it will simply get the information and then return back, okay, this is the account number after doing all the logic. The child class will just get the bank account number. That's it. It gets the bank account number and then it can use its own logic. Okay, send 200 rupees back to this account number. How that account number was received is hidden.
Ankit, like in future classes, like we'll get an exercise like using these functions and classes. Along with that, if and while these loop concepts, I mean, if conditions and while uh, for loops and these all concepts can be used in a single. Like we can have a task, right? Like
Yeah, you
in
will have a project, you will have, so let's say as and when you move ahead, right? When you implement your machine learning algorithms, when you move to statistics, all these things will be combined together. Most of the things you will have to start using together.
yeah, then at
And
the time it will be more comfortable and easy to practice, because
yeah,
it's completely theoretical way. Just we are remembering the concept, like
yes,
abstraction means what, and inheritance means what, polymorphism is what, and for is what, like that. Everything just we are reminding in our mind, and when it comes to the practicality or something, a task, whatever it comes in a future class, that time we'll get to know complete in and out, right, by
yes.
execution of the script. Yeah.
Yes. See,
Yeah.
most probably during your projects, right, the projects that you will do, all these things will combine together. Now you are studying Python. After some time, I think some of you might go to SQL. You will study statistics. You will study machine learning. Finally, all these things will be together combined in a project that you do. That will be a huge project. You will have to create classes. You will have to create functions. You will deploy these codes and so on. So at that time, all of the entire application of the entire course, not just Python, in fact, even your algorithms, everything, the application will happen inside the project.
Sure, sure. Thank you, Ankit. I got you.
Yeah, great. Okay, so
Hello.
yes,
Yeah, am I audible?
yes, you're
Yeah.
right.
So you have mentioned that we can only achieve abstraction from importing the class ABC, right?
Yes.
So is it wrong to say, or is it right to say that Python supports natively object-oriented programming? So is Python an object-oriented language, or is it more like functional language?
So, Gaurav, this is your first session, is that correct?
Yes.
Yes, okay. So, Gaurav, Python is an object-oriented programming. See, Python is
Okay.
a lot of things, but it's a high-level programming language. It's object-oriented programming language. It's also a scripting language. A lot of people use it for web development. A lot of people use it for very native scripting and all. But if you want to know, is it an object-oriented programming or is it just a scripting language? It is both, but it's not a native language. It's an
Okay.
object-oriented language.
All right. Okay. Thank you.
Yeah. So Gaurav, see, what I would request you to go and attend, do one thing. Okay, go through some previous session recordings if they are available to you, and you will see that why we have defined like why is Python an object-oriented programming? How does it deal with objects? What are objects? What are functions? And what is the entire definition? Once you go through that, come back and then we can have further discussion. Does that work?
Yeah, sure. Okay.
Let me give you 5 minutes to quickly make a note of this. Let me zoom out a little bit so that you can see the codes.
Ankit, in addition to the script which you shown and taught us, just added these lines in it, and I mentioned like s1 equal to square and s1 dot get lines. So in that case, how would be the output? Like,
You say class square shape, define get lines, return super dot get lines. Oh, I think Vinay, this is the previous code or this is shape. Okay, you have defined one more abstract. You are this is a part of abstraction or is
yeah,
this a part of
just I attached one more class like
yeah.
square I added, and then I ran.
Okay, then you in that case also it will work similarly. Okay, great.
But it is showing only the content what I mentioned in the above one. Like I'm a shape. I can have any number of lines. Only one statement got print.
Will it get printed twice?
Yeah, I expected, but yeah, only one time. Yeah, go.
Only one
I
time?
think
Okay,
it's
so
correct. It's correct. I think.
you have one more function, let's print it here. Class square, define shape get lines. No, don't use return here. This will be super because see your if you write down return here itself, right? What will happen is your function stops. Okay, class, one important topic here. Whenever you write down return, the function will return this value and it will also return back to the flow of control. That means this line will not get executed. Whenever you write down return in a function, it returns that value and the flow of control goes back and the further lines will never be executed. So let's remove this return. See, let me tell you what return will do here. Okay. What will return do here? It will return whenever you call s1.getLines, it will return this value. What is this value? I am a shape, I can have any number of lines. That is what will be returned. That's it. That's why you're getting one line. If you remove this and now execute, you should get
Yeah,
I am a
I got
shape.
two lines. Perfect.
Great. Okay. So I see that I think most of you are done. Please make a note of this as well that you cannot instantiate an abstract class. Please make a note of this as well. All right. So class, let's move on to the final pillar of your OOPS. This concept is called as encapsulation. And the technical definition of encapsulation is something like it says that the let me put it in a word where you can wrap the data into a single unit. That is what encapsulation is. If you open any tutorial, any book, it means that it is a concept of wrapping the data into a single unit. In a more practical terms, it is used to define the scope of the members. Let's now understand what scope of the members is. If you remember, while we were looking at the employee class definition, I would have mentioned that you would want to keep your members hidden. You don't want to tell the name of your data members, because if that is accessible, people will be able to modify it. Now, let me quickly do one thing. Let me quickly write down a class here. Let me quickly write down a class. Let's use some different class system. Let me say student and no inheritance. It's a straightforward. Let me define the constructor function init, and let's say it accepts certain values. Let me say name, roll number. Then after this, we can have, let me add just one more subject. Okay, and I'm going to define the data members as self dot stu underscore name, or let me say s underscore name. Is s underscore name is equals to name, then s self dot s underscore role is equals to role, and finally s underscore subj is equals to subject. So this is a class which has three data members: name, role number, and subject. Rather, s underscore name, s underscore role, and s underscore subject. And I'm going to define one more function here called as get underscore name. Okay, this function will take as input a parameter self, and it's going to return, let's say, s underscore name. Now, this is more a theoretical. This is again a theoretical concept, but I would want everyone to pay attention to what I'm going to do. Okay, so I have defined a class student which has two functions. One is the constructor function that has defined the parameters s underscore name, s underscore roll number, s underscore subject, and you're assigning the corresponding values. Then I have defined a function called as get name that will simply return the name. Now let me define another class called as, let's say, scorecard, and let me inherit the class student. So automatically all my, if you say I'm going to only write down the constructor function here, but yes, automatically all my data members and functions from the parent class will be available to my child class. Let me start. I'm going to obviously have self. The data members are going to be common. So I have name, roll number, I have subject, and let me add two new parameters, which are score 1 and score 2. These are the scores of the 2 semesters, let's say. Okay, I'm going to define. Now I already have 3 data members, which are available in my parent class. So I'm going to use my parent class constructor to initialize these values. Let me send name, roll number, and subject here. And then what I'm going to do is for the rest of the data members, I'm going to use and define the data members here. Let me assign the values here. So I'm going to say s underscore score 1 is equals to score 1. S underscore score 2 is equals to score 2. Let me register this inside Python's memory. Then what I'm going to do is class, I'm going to first create the parent class object. So my parent class object here will be what? I'm going to create, let's say, stu is equals to student. Let me create student object. Let me send out some name. Let's say John. And let's say the roll number is 1, 2, 3. Let me use numerical data here. 2, 3. And let's say the subject name is maths. Okay, let's create the parent class object. Then what I'm going to do is I'm going to call, using this object, I'm going to call the parent class data member, which is accessible. Now I'm going to create. Now let me do one more thing. What I'm going to do is I'm also going to check I'm going to access the data member inside the function, inside the class. So, and this is accessing the data member member using object. Okay. So this is your parent class object. Similarly, what I'm going to do is I'm going to do the exact same things for my child class. Let me first quickly access the data member inside the class. That can be done with the help of function student underscore get name. So what are the data member that I'm talking about? The data member that I'm talking about is this data member. The s underscore name. So if you see, when I create the parent class object, I'm able to access s underscore name. And when I'm calling the function get underscore name, right, what will happen is I will use this particular self is missing. I'm going to use this particular code, return self dot underscore name. That means if I call the function get name, I'm trying to access the member from inside the class. Okay, if you see, I'll get the name John. Similarly, I'm going to define a child class object. And I'm going to say, let's say marks is equals to scorecard. And let me say, shall we use the same person? Let's use the same person. In fact, let me say John 1, 2, 3, then maths. Then let's say in this object, just go 90 and 85. So what I'm going to do, I've created this. Now I'm going to say marks dot s underscore name. Can I access using the child class object? Of course I can. And then can I access from within the class? Of course I can. I'll do get underscore name, right? Since this is a parent class function, I will still be able to get it. Now what I'm going to do classes, I'm going to add a single underscore here. The moment I add single underscore, what has happened is the scope of the members is defined by adding or removing underscores in front of your data member name. So let me put it here. Underscore defines the scope of your member. Okay. How we are going to see in just a minute, scope of a member is defined by the underscore itself. If there is no underscore class, if there is no underscore in front of your data member, when I say no underscore, it does not mean inside or outside. The precedence or the first character itself. If you start your data member name with a single underscore, then you call it as protected. If there is no underscore before the variable, let me put it before the variable, you mean this is a public. This is nothing but a public data member. That means everyone can access it. Each and everyone can access it. So who is each and everyone? You can access it with the help of the parent class object. You can access it from within with the help of the object. You can also access it from within the class. The child class can access it, and the child class can also access it from within the class. It means everyone and anyone whoever has access to this particular class, they will be able to access s underscore name. If I keep it as s underscore name, okay. S underscore name indicates that this is a public data member. Now, what if I add one underscore? The moment I add one underscore, what will happen is this will become something called as protected. If you add a single underscore in front of the variable, you call it as protected. Okay, so let me put underscore s underscore name. Now, what will happen when you append it? See, if I put underscore in front of my variable name, you will see that everything is working as expected. Okay. Let me put underscore s underscore name here. When we're trying to access with the help of the parent class object or the child class object, you will see that I'm still able to access. But when you define a variable as protected, people who want to import, right? If someone imports your class, how you imported ABC? Similarly, someone can import your .py file. They can import your class. If someone imports, and we'll see tomorrow in the next session or maybe one or two sessions down the line, mostly I have planned for one session where we'll be looking at multiple for loops and how do we create packages, how do we import. At that time, you will see if someone imports, you will see how import works. If someone imports your class, they will not be able to access it. Okay, So what happens when you define a particular data member as protected? If someone has imported your class, they will not be able to access it. And finally, you have something called as private. Private means you add double underscores, and then only the class will be able to access your variable. Okay. If you add double underscore, only the class will be able to access it. You will see that even object cannot access it. So let me do one thing. Let me add double underscore here. If I add double underscore, if I add double underscore here, you will see that the moment I try to access the data member with the help of my parent class object, it will say that you do not have an attribute called as double underscore s underscore name, but you see 84, 85. I've executed the code. Why? Because if you put two underscores in front of the variable name, what will happen is you will see that this is a private member. Python will treat it as a private member. So although you see that you will be able to access it from within the class. So from within the class, you will be able to access the class itself can access the data member, but the objects won't be able to. Now the question that arises is, how do we know what should be defined as public, what should be defined as protected, and so on? See, public, it all depends upon what are your data members. There are certain variables that you as a developer, you would be okay with people modifying them. You can define them as public. There will be some variables where you want only people who are contributing in the same class should be able to modify. People who are importing, they should not be able to modify. Let them not allow, you won't want to allow them to modify any values. These can be values such as name, addresses, such values, right? Which are important to you, but you don't want anyone who does not work on your project. They are working on some different project, but they want to use your class. You say, okay, you use my class, but I'm going to protect some of my data members so that you cannot modify it. Otherwise, my class will fail. And then there are certain variables where you want not even the objects of the same class should be able to modify, not even your own teammate should be able to modify. These are values such as, let's say, your UIDs, your Aadhaar card number, PAN card number, your government IDs, like your DOBs. You don't want people to edit it. If you see Facebook websites such as Facebook or any social media website does not allow you to again and again edit your DOB as well. They say you cannot do that. So such variables where you do not want public or anyone else apart from the class itself, you want to control how this particular variable will be affected or how this particular data member will be modified. This is supposed to be under the control of the class. Then you will define it as private. Now, having said that these are the scope of the members. In the next session, I know we are already 6 minutes above our stipulated time. In the next session, I'm going to make another bold statement where I'm going to say that all this is fake. Okay. Actually speaking, if you're a smart Python developer, you will still be able to access your private variables. The scope, see, in Python, we do not have anything specific called as public, protected, private. Since this is an open source language, this is an indicator that this variable has to be treated like one. But there are ways you can anytime overcome, you will be able to access private variables if you are a good developer. How? In the next session, we'll start with that. But till then, let me give you a minute so that you can quickly make a note of this. Okay, I'll scroll as and when required. But let's quickly make a note of this. In the next session, I will tell you how to access private variables. That will take just 5 minutes, but after that, we will start with a topic called as NumPy. People who are done, feel free to drop off. People who are done, feel free to drop off. And let me know if you need me to scroll down. Just ping in the chat down so that I'll come to know that you need me to go down. Class, feel free to drop off if you are done. Also, class, if you have any question, let me know. I know we are well about time. Binay, I wanted to ask you one thing, Vinay and Gaurav. I think you two are only left. The rest of the people I'd asked last time. Are you available on Sunday from 10 to 1? Can we have a session from on Sunday 10 to 1?
Sunday at what time?
10 to 1 in the morning?
Yeah,
Yeah,
sure.
fine.
Yeah.
Fine
Like
with you,
ten
Binay?
thirty to actually 10:30 to 11, I have stand up call. So
On a Sunday as well.
yeah, actually I'm working for Middle East. So there we have
Okay.
Sunday. Friday,
So,
Saturday was a week off for us.
what time will suit you then? 11 to 2 will it suit you?
Yeah, that will be fine. Perfect.
Gaurav, 11 to 2 will it be okay with you?
Yeah, it will be okay.
Okay, then Sunday there will be an additional class that I'll set up from 11 to 2. All right. A Saturday evening we will have class as expected in the evening 9 to 10:30. And Sunday morning 11 to 2. I'll just inform your Innovit admin to set up a call from 11 to 2. Cool. All right. With that, I think with that, if we are good, let me close the session. Thank you, everyone. I hope you enjoyed today's session. We'll catch up again on Saturday.